We all know our computers are fast, right? But have you ever stopped to think about how they get to be so mind-bogglingly quick? Well, it's not just about the processor's raw power. Today, we're going to pull back the curtain on one of the CPU's most important but kind of hidden secret weapons, registers.
Seriously, why can your machine just launch a huge application or render a video in what feels like the blink of an eye? The answer isn't what you might think. It actually lies in a set of incredibly tiny, unbelievably fast storage spots. They're the true unsung heroes of modern computing.
So, here's our game plan for this explainer. We're going to start with a fundamental problem, the CPU's desperate need for speed. Then, we'll look at the brilliant solution and meet the specialized little workers that make it all happen. We'll see how they map out their workspace, how they navigate it with pinpoint precision, and then wrap it all up with why any of this actually matters to you. Okay, so to really get why registers are so crucial, we first have to understand the main bottleneck at the heart of pretty much every computer out there. It's a classic problem, really. You've got a super fast worker and a much slower supply chain.
Just think about your computer's central processing unit, the CPU. It's a beast, right? It can execute billions of instructions every single second. It is blindingly fast, but all the data it needs to chew on is stored in the main memory, or RAM. And RAM, when you compare it to the CPU, is kind of slow. So if the CPU had to just sit there and wait for RAM every single time it needed a little piece of data, it would spend most of its time doing, well, nothing, just waiting. That speed gap would bring your super powerful computer to a screeching halt.
So, how did the engineers solve this massive problem? Simple. They gave the CPU its own tiny, ultra-fast workspace. And this is where registers come into the picture. To really understand them, let's use a simple analogy.
First, let's get the technical definition out of the way. A register is just a high-speed storage location that is physically inside the microprocessor. It's the absolute closest, fastest memory the CPU can possibly access. But what does that actually mean in practice?
Let's imagine our CPU is a world-class master chef. This chef can chop, mix, and cook at superhuman speeds. They are all about pure efficiency and getting things done, fast.
Now, the main memory, our RAM, that's like a gigantic walk-in pantry. It's got every ingredient the chef could ever possibly need. Spices, vegetables, you name it, it's in there. But it's all the way down the hall. Every time the chef needs a pinch of salt, they have to stop everything, walk to the pantry, find the salt, and walk all the way back. You can see how inefficient that would be, right?
And the solution? It's the chef's personal workbench, the registers. It's this small little space right in front of them, holding just the few ingredients they need for the exact step they're working on right this second. No more long, slow walks to the pantry. Everything the chef needs is right there within arm's reach. And that lets the chef work at their full, incredible speed. Now, not every spot on this workbench is for the same thing. You know, just like a chef has a mixing bowl over here, a cutting board there, and a scale somewhere else, the CPU has different kinds of registers, and each one has a very specific job to do. So let's meet these general-purpose workers. All right, let's meet the crew. First up, the AX register. Think of it as the calculator. It's the go-to for all the math and logic. Then you've got the BX register, the address holder. This one's interesting. It doesn't hold the ingredient itself, but a little note that says exactly where to find that ingredient in the pantry. The CX register is the counter, and it's perfect for repetitive tasks, like if the chef needs to chop 10 onions, it just counts down from 10. And finally, there's the DX register, the data specialist. It handles the tricky jobs, like complex multiplication or talking to other gadgets in the kitchen.
Okay, so our chef has their amazing workbench, but that pantry is still huge. How does the CPU keep track of where different types of ingredients are stored in that giant main memory? Well, it uses a map. And this map is made up of what we call segment registers. You have the code segment, or CS, which points to the shelf where all the recipe books are kept. The data segment, DS, points to the big section with all the main ingredients. The stack segment, or SS, marks off a temporary prep area for mixing things together. And the extra segment, ES, that's for those really special exotic ingredients that you only use in a couple of recipes.
Knowing which shelf the recipe book is on is great, but that's not enough. The chef also needs to know the exact step in the recipe that they're currently on. For that kind of precision, the CPU uses another set of even more specialized registers.
And this is a really crucial partnership. The code segment register, CS, gets the chef to the right cookbook, but it's the instruction pointer, the IP, that acts like a bookmark, pointing to the very next line in the recipe that needs to get done. As soon as the chef finishes a step, the IP automatically moves to the next one. It's brilliant.
So what about that temporary prep area, the stack? The CPU has to manage that space really carefully. It uses 2 registers for this job. The stack pointer, or SP, which always points to the last ingredient you just added to the mixing bowl, the very top of the stack. And then there's the base pointer, BP, which marks the bottom. This helps the chef keep track of different groups of ingredients they might be prepping at the same time.
And finally, we've got the source index and destination index registers, SI and DI. Just think of these as the chef's 2 hands. They are total specialists at moving ingredients or data from one place to another really efficiently, especially when they're working with a whole series of items one after another.
So we've met the whole team, right? The general workers, the map makers, the navigators. But what's the big takeaway here? Why do these microscopic little components have such a gigantic impact on everything we do? Well, the crucial point, the thing that changes everything, is this. Registers are designed from the ground up to be accessed at a much higher speed than conventional memory. That one single design choice is what completely shatters that bottleneck we were talking about at the start.
And to bring it all back to our chef one last time, it's all about getting rid of that slow, painful walk to the pantry. By having the exact data it needs right there on its personal workbench, the CPU can work at its absolute maximum potential. That closeness, that proximity, that's what translates into the incredible speed you experience every single day.
So the next time an application just snaps open in a fraction of a second, you'll know it's not some kind of magic. It's the result of this incredibly elegant system of tiny, lightning-fast workbenches humming away inside your processor. These are the real unsung heroes of your computer speed, the registers.